Hello students, welcome back again to the lecture number 8 of chapter 7. In the previous two lectures, we have solved 4 questions from the exercise 7.1 based on 2 axiom and 1 theorem, that is ASA and SAS congruency, right? And today in this lecture, we are going to solve another 2 problems from the same exercise, right? So let us start the question number 5. So as you can see, according to the question number 5, there is a figure, and in this figure, the line L is the bisector of angle A. Okay. So as you can see, this is an angle, this is an angle, and name is angle A. Now, the line L, this is the ray or straight line L, which bisects this line. It means L is the angle bisector of angle A. What is an angle bisector? An angle bisector is a line which divides the angle into 2 equal halves. It means this part is equal to this part. It is clear? Okay, next. Now, B is any point on L. So, on this line L, we have to take a point B. Suppose this is a point B on L. And BP and BQ are perpendiculars from B to the arm A. So we have to first understand this sentence, particularly this sentence clearly. Okay, it is given that arm of A, right? Since A is the angle, if we take it to be C and this to be D, right? Then for this angle A, it has 2 arms. One is AC and one is AD. This is clear now. Now it is given that BP, this is B, and BP and BQ are perpendiculars. These are the perpendicular lines from B on or to A, the arm of A. It means you have to draw perpendicular line from B to the 2 arms. Suppose this is the arm AC, then you have to draw a perpendicular. Perpendicular means 90 degree on this arm AC. Similarly, you have to draw another perpendicular line on the arm AD, like this, like this. Do you understand it? Okay, so it is given that you have to draw BP and BQ are 2 perpendiculars on the 2 arms, that is AC and AD. Okay, now the statement is clearly understood. So now you have to prove or you have to show that the triangle APB, which triangle? APB, this triangle, and the triangle AQB are congruent. This is the first statement we have to prove, and the second statement you have to prove that BP is equal to BQ. It means the perpendicular distance from B to AC and from B to AD are equal. Okay, so let us first prove the first statement. So first write what is given in this question. In this question it is given that L is the what? L is the angle bisector. So L is the angle bisector. So can we write this angle is equal to this angle? Yes, we can write. Okay, this angle means PAB. So you can write PAB angle is equal to this angle QAB. Right? Okay. And it is given that BP is perpendicular on AC. Clear? And BQ is perpendicular on this arm AD. Clear? Now we have to prove that these 2 triangles are congruent. So what to prove? Write it. To prove. First thing we have to prove that triangle APB is congruent to the triangle AQB. And the second statement is you have to prove that this BP is equal to BQ. Okay, so always write them in proper order. Let's prove the first statement. So for the first statement we have to compare these 2 triangles. So between triangle APB and triangle AQB. Let us find and identify through which congruency they are congruent. Okay. So as you can see here, this angle is equal to this angle. Yes or no? Yes, this angle is equal to this angle. And this angle is also equal to this angle. Suppose we take it as 30 degree. Then what is the value of this angle? It will be also 30 degree. It is an example, right? And it is 90, it is 90. So if we consider this triangle, only this triangle, right? Then what is the value of this angle? This is 30, this is 90, then it will be 30 plus 90 is 120. So 180 minus 120 is 60 degree, isn't it? Right. Similarly, if it is 30, it is 90. And what is the value of this angle for the triangle AQB? It is also 160 degree. So what we get from this data? We get that if two angles of one triangle is equal to another two angles of another triangle, then their third angle must be equal. That I have told you in the previous lecture. I have taken the two groups. Yes or no? Balam, Abhay and Jitendra, Jyoti, Gautami, Kishori. I have told you, if Balam has 50 rupees, Abhay has 130 rupees and the total has 200 rupees. Similarly, Jyoti has 50 rupees, Gautami has 130 rupees and the total has 200 rupees. Then, if Balam's money equal to Jyoti's money, Abhay's money is equal to Gautami's money, then can you say that Jitendra's money is equal to Kishori's money? Yes, because they are added to give 180, then it will be 20. Similarly, they are added to give 180, then it will be 20. So if any two persons' money is equal to another two persons' money from the second group, then the third person's amount will be set. Same procedure is followed here. Okay? Do you understand it? So now we will compare these two triangles. First case, we can write this angle. This angle means APB. APB is equal to, in this triangle, this angle AQB is equal to 90 degree. Why? Because it is given. So this stands for angle, right? Next, as you can see, okay, let us do not take this angle. Do not take this angle. We will take other angle. As we have clearly found that this angle is equal to this angle. Yes or no? Okay, yes. So we can write this angle is equal to this angle. So that it is easy. So this angle is equal to this angle. This angle means ABP. Okay, we are considering this two angle, not 90-90. Okay. So ABP is equal to ABQ. Right? Why? You write the reason. Because if in two triangles, two angles or two corresponding angles are equal, then their third angle must be equal. Clear? Next thing. Okay. See, if we consider this triangle, then AB is the side. AB is a side for the triangle APB. And if you consider AQB triangle, then AB is also another side for the triangle AQB. It means AB is the common side to both the triangle. So AB is the common side to both the triangle. Understood? Third condition is that it is already given that A is the angle bisector. It means this angle is equal to this angle, right? So PAB is equal to this angle QAB. Why? Because L is the angle bisector. Understood? Now we have found the three conditions. Let us identify which congruency it is. Now we get that in this triangle which angle? This angle, this angle. See, this angle means this angle, this angle means this angle, and this side. So angle, side, angle. Similarly here, angle, side, angle. So by ASA, this stands for angle, this stands for side, this stands for angle. So by ASA congruency, this triangle is congruent to the triangle AQB. This is the proof for the first statement. It is clear now? Okay. Next thing we have to prove the second one. This one. How? Since we have found that this triangle is congruent to this triangle. Now remind the axiom number 7.2. We know if two triangles are congruent, then their sides must be equal. Right? So if we consider this triangle, then BP is a side, yes, of triangle ABP, or you can say APB, whichever you can take. Similarly, if we consider this triangle, then BQ is a side of the triangle AQB. Yes or no? Yes. But we know these two triangles are congruent. Then we can write that their side must be equal. So we can write BP is equal to BQ. Why? Because due to axiom 7.2. Now it is proved that the perpendicular distance from B to the two arms SC and AD are equal. It means BP is equal to BQ. Okay, understood? And now coming to the question number 6. Okay, so in question number 6, as you can see, here is a complicated figure. Okay, it is a little bit complicated figure, and from this figure some data are given. It is given that AC is equal to AE. So let us first find and identify which one is AC and which one is AE. So it is given AC, this side, is equal to AE, this side. Understood? And AB is equal to AD. AB means this is AB. AB is equal to AD. Right? And BAD angle, BAD, this angle is equal to EAC. Okay? EAC, this angle. So it is given that this angle is equal to this angle. Right? So now from this data you have to prove that BC is equal to DE. BC means this total length BC is equal to DE. DE means this portion. Okay. So in order to prove that BC is equal to DE, first we have to think which two triangles must be taken and they should be congruent so that we will get BC and DE. Okay, we have to think about this. Now tell me, BC, this BC, okay, is a side of which triangle? First tell me that. BC is a side of which triangle? This triangle? ABC triangle, yes or no? Yes. So you have to ultimately choose triangle ABC. Okay. Then DE. DE is a side of which triangle? See, which triangle? This triangle. ADE. Okay. So ultimately we have to take the triangle ADE. This should be keep in your mind. Okay. So we have to compare these two triangles. Now, how we can compare them? Let us compare. So first we have to write what is given. Solution. So it is given that SC is equal to AE. Clear? AB is equal to AD. And angle BAD is equal to angle EAC. Okay. So now to prove, we have to prove that BC is equal to DE. Proof. Okay. Let us compare these two triangles. So between triangle ABC and triangle ADE. So let us compare them. First case. In triangle ABC, again I am telling you this triangle ABC, ABC, not ABD, ABC. Okay. In triangle ABC, this side AB, okay, is equal to which side? We have to take this triangle ADE. So this side is equal to this triangle. Which side? This side. Why? Because it is given already. AB is equal to AD. It is already given. So you can write AB is equal to AD. Okay. Now why it is given? Second case. Now, if we consider ABC triangle, ABC triangle, right? ABC triangle. Now, the angle A is, this portion is angle A, not only this portion. Which portion? The total, this portion is angle A, not this. Because if you take this angle, then it is the angle for the triangle ABD. Clearly look at it. I have told you that we have to take this total angle because this total angle represents angle A of the triangle ABC. Right? Similarly, if we choose ADE triangle, then this total represents angle A. Not only this. No. This angle represents which triangle? This triangle, ACE. But we have taken ADE triangle. So clearly look at this. But we don't know whether this angle of the triangle ABC is equal to this total A angle of the triangle ADE. Did you know it? No, we don't know it. We only know that this small angle is equal to this small angle. Okay, so let us find how they are equal. It is also very interesting to see. Okay, see. Since this angle is equal to this angle, it is clear. It means, suppose we take this as 60 degree, then what will be the value of this angle? It is also 60 degree. Yes or no? Yes. So it is given ABD is equal to 60 degree, and this angle means which angle? Sorry, not ABD, this is BAD. I have written BAD, and this angle means CAE. Clear? So CAE is also 60 degree. Now, if we choose this angle, this small angle, to be 30 degree, suppose we choose this angle to be 30 degree, right? Now, tell me what is the value of BAC? What is the value of BAC? Okay, can we write BAC is equal to this small angle plus this small angle? Yes or no? Yes, we can write. This angle means BAD plus this small angle BAC is equal to 60 plus 30 is equal to 90. Clear? Carefully look at this. Now, since we get CA is equal to 60 degree. Clear? Now we have to find this angle, the total angle. This total angle means DAE means this total angle. How can you find this? This angle plus small angle. So 60 plus 30 is equal to 90. So what do we get? We get that in this triangle ABC, BAC is also 90 degree, and in the triangle ADE, this angle DAE is also 90 degree. Okay, since we have taken this is 60, this is 60, and this angle is 30 degree, that is why we get 90 and 90. It means these two angles will be equal. Why they were equal? Because since this small angle is the common angle to both the angle, and both the angles are equal, we know from the axiom. Remind the chapter number 5. We know since it is 60, this is 60. If same number is added to both equal numbers, if same number is added to two equal numbers, then the result will be equal. This is the, I think, axiom number 5.2, I think. Okay, since it is the common angle to both the angles, so this angle plus this angle is 90 or whatever you can take, and this angle plus this angle is also equal to that angle. Okay, so we can now write that in this triangle, the total angle, this total angle means BAC is equal to, in this triangle, which triangle? ADE, this total angle also equal. So which angle? Angle DAE. Understood? Why? Due to axiom? I think 2. I think yes, axiom or postulate 2. Okay, from the chapter 5. Next. Now you see, in the triangle BAC, this side AC is equal to, if we take this triangle ADE is equal to this side or not? Yes, it is already given that AC is equal to AE. It is given AC is equal to AE. It is given. So in this triangle, this side AC is equal to, in this triangle, this side AE is equal to AE. Why? Because it is given. Right? Now what we find? We find that in this triangle, this side means AB, this side means AC, and the included angle, this one, included angle, are equal to this triangles, this side, and included angle. So it considered as a S congruency. So we can write by SAS congruency, triangle ABC is congruent to the triangle ADE. This is clear now? Okay? You can write by SAS congruency or axiom number 7.1. Clear? But our target is to prove BC is equal to D. How? Since these two triangles are congruent, it is clear. We know if we consider this triangle, then BC is a side of this ABC triangle. If we consider this triangle ADE, this, then DE is a side of ADE triangle. But we know the triangle ABC is congruent to triangle ADE. Then according to the axiom 7.2, we can write that their sides, their corresponding sides are equal, or CPCT. So we can write BC is equal to DE. Okay, by axiom 7.2 or CPCT. Hence it is proved. Okay, it is very interesting question. Understood?